SpaceX is developing a new generation of Starship. But Starship V3 isn't simply a bigger rocket. It represents a major step toward a more powerful, more capable, and more reusable launch system. So what exactly has changed from V2 to V3? Let's understand.
SpaceX is developing a new generation of Starship. But Starship V3 isn't simply a bigger rocket. It represents a major step toward a more powerful, more capable, and more reusable launch system. So what exactly has changed from V2 to V3? Starship V2 already demonstrated the enormous potential of SpaceX's fully reusable launch architecture. But V3 is designed to push that architecture further, with improvements to the vehicle's size, propulsion, structure, and overall performance. The goal is simple: carry more, fly farther, and make each launch more capable. One of the most visible differences is the vehicle's overall size. Starship V3 is taller than the previous generation, creating additional room for structural improvements, propulsion systems, and future mission requirements. This increase in scale is not just cosmetic. Every additional meter is part of a larger engineering effort to increase the vehicle's capabilities. The Super Heavy booster is also evolving. V3 is designed with a more powerful booster architecture, allowing it to generate greater thrust during liftoff. That additional performance could help Starship carry heavier payloads while maintaining the energy needed to return the booster for another flight. At the heart of this system are SpaceX's Raptor engines. V3 is designed around an upgraded propulsion configuration, with improvements intended to increase thrust, efficiency, and operational capability. The engines are critical because every improvement in propulsion can translate into greater performance across the entire mission. More thrust at liftoff means more energy available to accelerate the vehicle. And that can ultimately translate into greater payload capability, improved mission flexibility, and more room for future upgrades. In other words, V3 is being designed not simply to launch, but to launch with greater performance. Inside the vehicle, SpaceX is also refining the architecture that stores and manages its propellants. The tanks, plumbing, structures, and systems that connect the engines together must operate under extreme forces and temperatures. Improving these systems is essential if Starship is ever to become a truly reusable transportation system. Then comes one of Starship's greatest challenges: atmospheric re-entry. After traveling through space, the upper stage must survive enormous heat as it falls back through Earth's atmosphere. The thermal protection system therefore remains one of the most important technologies on the vehicle. Every improvement here could make future Starship flights more reliable and easier to maintain. All of these improvements lead toward one major objective: payload. A more capable Starship could eventually place much larger spacecraft, satellite constellations, and other payloads into orbit, and that could dramatically change the economics and scale of space transportation. But Starship's ambitions extend far beyond low Earth orbit. For deep space missions, SpaceX is developing the concept of orbital propellant transfer. One Starship could transfer propellant to another in orbit, allowing a fully fueled vehicle to begin a much longer journey after reaching space. That capability is especially important for the Moon. NASA's Artemis program envisions a Starship-based human landing system for future lunar missions. A reusable and refuelable Starship could potentially deliver people and large amounts of equipment to the lunar surface. And beyond the Moon is Mars. SpaceX's long-term vision for Starship is to create a transportation system capable of carrying people and cargo between Earth and Mars. That is an enormous challenge, requiring reliable launch, orbital refueling, long-duration spaceflight, and eventually safe atmospheric entry and landing on another planet. So, when we compare V2 with V3, the story is much bigger than a simple increase in size. The evolution involves propulsion, structure, thermal protection, payload capability, reusability, and the infrastructure needed for missions beyond Earth. V3 is being developed as another step toward a much more capable Starship system.
The real question isn't whether Starship V3 is bigger. It's whether these changes can make Starship reliable enough to transform how humanity reaches space. Because if SpaceX succeeds, Starship could change not only how we launch satellites, but how we explore the Moon, and eventually, Mars. From reusable launches around Earth, to future missions to the Moon, and eventually, perhaps, to Mars. Starship V3 represents SpaceX's attempt to build something far larger than a conventional rocket. A transportation system designed for humanity's next chapter beyond Earth. V3, the next evolution of spaceflight. I'm Dr. Maya Carter. Thank you for watching the Cosmic Dialogues. If you enjoyed this journey through the future of spaceflight, make sure to like this video and subscribe to the channel. Thanks for watching.